Here we're going to look at the Gaussian model and the logistical growth model. First of all, a Gaussian model is used to represent items that are normally distributed. And in other words, we're going to create a bell curve. So when I look at my graph, I'm going to have something that looks sort of like this. And I'm going to be interested in finding the average. And the average is always going to be represented by the maximum. So really, a Gaussian curve problem is really finding what is the maximum of the bell curve. Now, with this, we're really looking at this as a calculator problem, not a lot of math behind it. So when you're given a Gaussian model problem, we're going to plug into our calculator, we're going to analyze the data points, then graph those data points and see what the average is going to be. So in this problem, we've got math scores. Y equals 0.0399 e raised to the negative x minus 74 squared divided by 114. Now, there's one key piece that we can see about this equation, and it's this piece right here, this x minus 74, quantity squared. Remember, when you're inside a quantity squared, that indicates a horizontal shift. And since this piece is in the exponent, it's also representing a horizontal shift. So this is actually going to be 74 units to the right if I look at it from a horizontal shift perspective. So that's going to be one of our starting points as we look to graph this equation. So we'll start by plugging it into our calculator into the y equals area. 0.0399 e raised to the negative x minus 74 quantity squared divided by 114. Now if I go to my normal zoom standard view and graph it out, I'm not going to see too much. And the reason for that is that the numbers are so small that we're working with. Let's go to our table, and we're going to start our table at 0, change of table being 1. You can see here I'm 5 times 10 to the negative 23rd, 2 times 10 to the negative 22nd. Those values are so small that they're insignificant for us. So we're going to scroll down the table until we find values that we can actually make some sense of. So keep scrolling down. 10 to the negative 9, negative 8, negative 7s. Okay. And around x equals 54, I can start seeing some values that I can deal with. Still a very small value, but a good starting amount. I'm going to continue along, and you can see these numbers are getting larger. And then right around 74, like we assumed, it looks like we hit a max, and then my numbers are decreasing. And as you look at it, it looks like there's a mirror image on both sides, because here at 73, it's 0.03955, and at 75, it's 0.03955. So continue to scroll along. And you can see once we hit 95, we get into these real small numbers that are going to be insignificant. So I'm just going to set my window as being x equals 54 and x equals 100. There is no right or wrong to the exact cutoff for what you set your window, but there's no reason for me to include anything less than 50 and anything greater than 100 because they get so small to begin with. The other thing I look at are the y values then. We made a good estimate that at 74 that was going to be our max based off of what we started over here. And if I look at my y values, I can see why my y max looks like it's going to be 0.0399. So those are some good pieces to look at as we set our window. So here I said my minimum x is 54, my maximum x is 100, and my y max is going to be 0.0399. So we'll go to our window. We'll set our x min being a little bit less than 54, which is 50, and then x max being 100. Remember, there's no absolute right or wrong for these window settings. And then I can take 1/10 of that, which is going to be 5. The y min, say 0 up to, if I say 0.0399, let's go a little bit bigger than that and say 0.05. And if I take 1/10 of that, I'm going to have 0.005. So let's hit graph and see what this graph looks like. There's that bell-shaped curve that we were looking for. So we'll draw a quick sketch of that bell-shaped curve. Just an approximate shape there. And if we do it this way, we're going to want to make sure we set up our scale as being, we were going from 50 to 100. And actually, I don't want to even put this axis right there because that's really non-existent. So I'll wipe that out. But we're going from 50 to 100. And I know that my height here, I said, was 0.05. So we do want to label our axes. So now if I go to my graph and I go second calc, I can calculate my maximum, because the maximum is what I wanted to find with this whole Gaussian curve. And you can see the maximum is 73.99997, which is really close to that 74, which is what I predicted it would be from my initial shift.